We're now going to look very quickly at some typical valves you'd find in a hydraulic circuit. We're not going into detail because this is really only because the next module covers some basic hydraulic principles and some formulas, so it's handy to have an idea of what that relates to, or very useful to know what that relates to before you start trying to follow them. So if we look at our circuit, we can see here this should be blocked, but it's a spool valve, so there's a tiny orifice. So exaggerated speed drop, but with a small orifice there will be leakage because we've got a load here. We can change the load, but whatever the load is, it will be causing a pressure drop across that orifice, which will cause it to leak. If we add PO check valves, so we've got almost a virtually leak-free seal here. You can see it stops the creep because the leakage is virtually zero. The orifice is very small if there's one at all. Now if we increase the load, we can see directly the pressure, the mass on the piston against the piston area creates a pressure which we'd see just here. The rest is open and low, but we'd see the pressure there. So we've got a force on an area which gives the pressure. Let's get through all. We now have got our flow control valve, so we can actually control the flow by changing the size of an orifice. So as the pressure drop across that orifice changes, that will affect the flow as well, but also as we change the size, you can see the speed changes because the flow will reduce. For the same pressure drop, the flow will get lower the smaller the orifice. So if we just do that again, as we gradually close it, gradually gets slower. We see the pressure still on the system there. So that's all I really wanted to do at this stage. We'll go through this in more detail later, but it should just help with the next sections on fundamental principles.